Hello everyone, I want to show you something. This is my little project. I did a satellite. Here first I must install the model of real attention. And this is my script. This is the definition of the model. And here this is the operation. First doing the attention, and the attention here is the axial attention. And then after that we adjust the output and then enter the embedding, and then after that we process the output to the dense layer, and after that we output them. Our topic in here is not that. The topic in here is what happened, in this model, the script. I'm using 1600 neurons. In here, this is the hidden dim, and hidden dim is used to the here in the dense layer. What happens if we run this? Okay. Here we have the first iteration. Loss is 1.001. Wait for the next iteration. Here we have the second iteration going down. Let's see for the third. Oh no, I mean second effort. First effort and second. And as you can see here, the third effort is the same with the second effort. Let's see for the fourth effort. So it's same. Let's see for the fifth effort. And it's same. Let's stop this. I think will be useless because you see here the loss mean is keep same. And what the meaning of this? The meaning of this is our model can learn from the training data. Why this happen? This is happen because the vanishing gradient. Vanishing gradient is the reverse of the exploding gradient. So when vanishing gradient, like its name, vanishing gradient, so the gradient will be zero. And because the gradient is zero, then the loss mean will not change. So that's why our model can learn anything. And to prevent that, or to minimize the effect of this vanishing gradient, usually in the deep learning, usually they will be doing something like ResNet, or they will be using here the batch normalization. Let's comment out this. I already built the script actually. We will use this. So as you can see here, the difference between this and this is in this, for every dense layer after the process of the dense layer, it's always followed by the normalization, and this normalization is here the best norm one dimension. This is the formula for the best normalization. This is actually just using a mean and standard deviation. So let's see what if we use this. Okay, we get the first import, second import, the loss is going down. Let's see for the third import, it's going down too. And for this case, when we using the base normalization, as you can see here, the imports 3 and imports 2 is different, right? It's not the same like in our first try. And as you can see here, for the 4 imports, it's different. with the epoch third and epoch second, right? It's going down. Let's see for the epoch 5. Yeah, it's going down, but the gap between 4th and 5 is very little. But at least it's not same like in our first. I think that's all. And that's how batch normalization can say it's prevent. It just minimalize the vanishing gradient effect. Thank you.